All of you, good morning. My name is Shekar. I am working as assistant professor in Shekar College, Shekar Engineering College. I am deals with applied physics. So today we discussing what is the quantum mechanics and black body radiation and Planck's radiation law. Okay, see that. Quantum mechanics. What is the quantum mechanics first? It is the branch of physics which explains the motion of microparticles like electrons, protons, etc. It introduced by Max Planck in 1900s centuries. Is developed by Einstein. He is applied and photoelectric effect. Einstein is applied and photoelectric effect in the quantum codes. The classical mechanics. It is the branch of physics, same is also branch of physics, which explain the motion of macro particles. What is the macro particles? This any bench or stools we see by human eye. That is the macro particles or macro objects. It is introduced by Isaac Newton in 1684. The classical mechanics is failed in explain of black body radiation and photoelectric effect and Rampton effect. So this concept explained by using a new concept, that particle aspect of radiation. So microscopic variations. So using a concept of quantum mechanics, the need to using of quantum mechanics, the very basic ones, the radiation. What is the black body? The classical mechanics is fails in the black body and photoelectric effect and Rampton. First, we're discussing of the black body radiation and how to modify the by using of quantum methods. The produced by the Max Planck. So Planck's radiation law also we're discussing about the this chapter. Black body radiation. A body that completely absorbs all wavelength of radiation. A body that completely absorbs all wavelength of radiation or emitted different wavelength of radiation at high temperature is known as a black body. Once again, I will tell you, a black body, this one is a black body, completely absorbs, the black body is completely absorbs all wavelength of radiation at a low temperature. Black body is at a low temperature, absorbs all wavelengths, or the black body emits different wavelengths of radiation at a high temperature of the black body is known as the black body. This one is the black body. Otherwise, not a black body. A body that absorbs the entire radiation incident on it called a perfect black body. Entire radiation on incident the absorbs, that is a perfect black body. But the no black body in the perfect black body in the nature, because of all someone is the wastage of the radiation. So entire absorbs is the not possible in the nature. A body that absorbs an entire, okay, and the radiation emitted by all frequencies, good, and this black body is radiation emitted by all frequency, and the black body is the emitted by all frequencies, good, and this is black body radiation. Okay, in the practical, okay, we know that already discussing about this point. Black body construction and working. An ideal black body, we know only not a perfect black body, is the ideal black body. We're discussing ideal black body, is the assumption. Ideal black body can be made by holosphere. Like the holosphere, see the picture, this is the holosphere. Holosphere cavity and drill a small hole. This is a small hole. And its inner surface is coated with the lamp black. This holosphere inner surface and outer surface. This inner surface is coated with the black ash or black lamp. Okay, and any radiation enter into the cavity through the hole. The radiation is through the hole enter into the cavity. See the picture. This one is the holosphere. This is the conical projection because of the number of reflection. And this one is a hole and surface coated in the black lamp in the surface. Okay. This one is a illustration of the black body picture. The radiation incident on the inner surface of the cavity. Okay, first one is the inner surface of the incident of the inner surface, the cavity. It's partially absorbs and reflected. This process is keep on continue multiple times. Means the partially absorbs by the black body the radiation and reflected partially. This process in keep on continue. So incident on the angle is like this and partially absorption and partially reflected. Okay, now another point is also partially absorption and partially reflected. Partially absorption, partially reflected. Partially absorption, partially reflected. The number of multiple times of the this process is continued. So by this using of this continuous process, the black body is heated. When the cavity is heated, the radiation comes out through the aperture or hole and contain all wavelength of the in the radiation emitted radiation. This emitted radiation is the contain all wavelengths. Okay. This is black body working. Its spectrum can be analyzed. The emitting spectrum outside of the coming outside of the after heating the black body, the emitted radiation or spectrum can be analyzed by drawing graph. We take the graph, the emitting power on the y-axis and different wavelength on the x-axis. Okay. See the graph, you see. And the given temperature that radiation and energy density intensity is increases. Okay, first see the picture graph. This on y-axis is the energy or intensity, emitting energy or intensity, and x-axis is the different wavelengths. Suppose 500 nanometers, 1000 nanometers, 1500 nanometers, 2000 nanometers. Okay, this is the emitting energy. What is the first point? What is the analyzing? The given temperature, the radiation, the given temperature radiation, any point, the radiation, the number of different wavelength radiation emitting spectrum is a different one temperature, another temperature. At the different temperature is a 3000 Kelvin and 4000 Kelvin the way and 5000 Kelvin type spectrum. 6000 Kelvin spectrum, 7000 Kelvin spectrum. So given temperature, the number of different given temperature, the radiation of energy density initially increase with increasing wavelength, then peaks at the around the particular wavelength, and after that decreasing finally zero at the high wavelength value. So what is analyzed? First point is the different temperature or given temperatures. We take the one spectrum line, the wavelength is increases, intensity also increases. First one is the wavelength is increases. This one is the wavelength spectrum. Is the wavelength is increases. The intensity also increases. Wavelength is increases, and wavelength intensity also increases. Wavelength is increases. The intensity also increases. Wavelength is increases. Intensity also increases. At the particular point, this one is a particular point is the peaks energy, peaks intensity, and this given temperature, this point also peaks and intensity at the particular wavelength. This one also particular wavelength gives the peaks and intensity. So after that, after peaks wavelength, the wavelength is increases, the spectrum intensity is the decreases. So this is the first point. And up to increases wavelength, the longer wavelength is the spectrum is intensity is the zero. This is the first point. And next, at a given temperature, the intensity of radiation is maximum. The given temperature, the intensity of radiation, this intensity of radiation is maximum at a particular wavelength. At the particular wavelength is the intensity is a maximum. Okay, this point is a particular wavelength, the maximum. This particular wavelength is the lambda m, indicated by lambda m. With a increasing in temperature, lambda is increasing. With the increasing the temperature, suppose this temperature, when is spectrum temperature is increases. Suppose 3000 Kelvin is the particular lambda, peak wavelength is the this point. Means suppose 1000 and 4000 Kelvin, the peak wavelength is the decreases. Suppose 700. Suppose 5000 Kelvin means temperature is increases. The wavelength, peak wavelength, only peak wavelength is decreases. See like this picture in the graph. The peak wavelength is decreases. This point is this point is, and this point also, this point is the decreases. This pointed to this pointed decreases. This pointed to this pointed decreases. So second point is given temperature. The intensity of the radiation is maximum at the particular wavelength. Okay, we discuss the increasing the temperature lambda means the decreases. And next point, for all lambda, any lambda, an increasing temperature, suppose increasing temperature 300, 4000, 5000, 6000 is causes an increasing energy emission also. With 3000 is given the fixed intensity is the very low point, and 4000 is the sum is the increasing intensity. 5000 Kelvin is the increasing intensity. 6000 also very increasing. 7000 also very increasing. So temperature is increases, intensity also increases. Some various given statement. Other scientists using this block body, they given the some statements. What are they? We discuss. This is the by using of analyzing graph. The overall 4 points is there. Next, first scientist is Stephens and Bolgian. The both scientists is given the one statement. What is that statement? The total energy radiation emitted from a black body, the total energy of radiation emitted from black body at temperature is proportional to the fourth power of the absolute temperature. Suppose energy is proportional to the fourth power of the absolute temperature. So sigma is extra, is not right. E proportional to E power 4 is the Stephen-Boltzmann law. We neglecting the proportionality, we get the E equal to sigma E power 4. The sigma is called a Stephen constant. Stephen constant value is 5.67 into 10 to the power of 8 minus 8, sorry, units watts per meter square Kelvin power 4. Wien's law. The peak's wavelength lambda max. Wien's law is discussing. Wien scientist is given the another statement. The Wien's law. That is the Wien's law. The peak's wavelength lambda max means peak's wavelength point at which the maximum emission at the peak's wavelength point, the maximum emission occurs for any given temperature is inversely proportional to the absolute temperature of the body. So at the peak point, lambda max, the energy is inversely proportional to the absolute temperature. Peak wavelength, the peak wavelength maximum emission. How much the emission is the equal to proportional to the 1 by T. T is the absolute temperature. This proportionality neglected, we get the B constant. B is the Wien's constant. This one is the Wien's constant. Wien's constant B equal to, what is the value? 2.89 into 10 to the power of minus 3 meter Kelvin. And next, Rayleigh-Jean's law. Rayleigh-Jean's law, the energy distribution, we see the directly is given the, according to Rayleigh-Jean's, is given the one equation E lambda, E suffix lambda equal to 85 kT by lambda power 4. So energy or intensity is inversely proportional to the lambda power 4, fourth power of the lambda in inversely proportional. So the Rayleigh-Jean's law holds good in a region of longer wavelength, but not for shorter wavelength. Is the meaning? Because of, we see the picture or graph. The what is the formula? What is the given equation? Rayleigh-Jean's, according to Rayleigh-Jean's, thermal spectrum is, according to is given equation is E equal to 85 kT by lambda power 4 means E always inversely proportional to the lambda power 4. Okay, so intensity is the intensity and lambda is the on x-axis we increasing and intensity is increases. But E is according to Rayleigh-Jean's inversely proportional to the lambda power 4 means inversely power 4. So intensity and wavelength is both are in decreases. Both are inversely proportional. So this one is the first see one spectrum, 7000 spectrum, Kelvin spectrum. We take that increasing the wavelength. Intensity also increases. Both are proportional. So this one is the wrong because of this is a shorter wavelengths. After longer wavelengths only work outing. So increasing the wavelength, the same 7000 Kelvin spectrum see like this is increasing the wavelength increasing. But intensity is decreases. So the Rayleigh-Jean's law is working only longer wavelength spectrum lines, not a shorter wavelength spectrum line. So by using this not explained. So this one is the classical mechanics is failed. So when the classical mechanics is played to explain the frequency distribution of the black body radiation, not correctly distribution, how to distribute it, not correctly. Why are you not given the lower energy is the increasing the shorter wavelengths? Why are you decreasing the longer waves? Not given the correct statement in the according to religions. So the Max Planck attempted and to find the first mathematical expression of the rectify the classical mechanics and rectify the shorter wavelengths distributions. Why are you distributed like this? Okay. What is the Planck's quantum theory? Okay. Planck's quantum theory. The 1901 Planck derived a theoretical explanation or expression for the energy distribution on bodies of the quantum theory of heat radiation. According to him, energy is emitted in the form of packets. According to Planck, the energy is not a radiation type. It's a come out emitted in the form of packets. Is taken the packets. The assumption the packets or quantum. This packet is called a quanta, called a photon. This packet is called a photon. Is assumption the photon. The photon has an energy E. One photon energy E equal to h mu is taken h mu, where h is the Planck's constant and mu is the frequency. And the energy E, the bracket energy equal to h mu, h is the Planck's constant and mu is the frequency. In this energy is not emitted. In this energy is not emitted continuously. Is there said another point? What is that? The energy is not emitted continuously, emitted in integer multiple. What is that? Integer multiple means not a continuous, 0 to infinite, not a radius like a continuous, and integer multiple. Suppose integer multiple means equal nh mu. Nh mu and n means integer means 1, 2, 3 up to infinite. So 1 h mu, 2 h mu, 3 h mu, 4 h mu up to n infinite h mu. But not a 1 by 2 h mu, 3 by 4 h mu, 2.5 h mu. Not a like that. That is a not a integers. Integers means specific 1, 2, 3. That one. Okay, no? 1 h mu. 1 plus 1 is 2 h mu. Only the fixed. The basic is the 1 h. Okay. The starting of the 1 h. Derivation of the Planck's law. How to derive? How to given the state equation? How to expression the equation? The number of oscillation and the energy state and energy state. Number of oscillation of the atoms En equal to nh mu is determined by the Maxwell-Boltzmann distribution function. According to Maxwell-Boltzmann function, the number of oscillation in the energy statement is En equal to nh mu. En equal to nh mu. According to Maxwell-Boltzmann, the even Nn, the number of oscillations, Nn equal to and not exponential of minus En by kT equal to the simply write and not minus e raised to minus nh mu by kT. The both are same. Exponential are e, both are same. So we write like this or this one also right. Okay. Here N naught is the number of oscillation in the ground state. N naught is the ground state. So let us N is the N oscillation at the absolute temperature. We take absolute temperature according to Maxwell-Boltzmann equation. What is that? And N suffix N equal to N. N is the at the absolute temperature oscillation. N oscillations E raised to minus En. E suffix N. E is the energy. N is the nth levels by kT. Next. Okay. Where N is N naught is the ground state, we know that already. Energy of the oscillation assuming discrete value. We know that already is discussing of the Planck's is given the not a continuous. So it is the energy is the discrete value. Sum of the all energies or average energy E of the oscillation is given. En, the nth level, number of energy levels is there. So En equal to NH mu and is the 1, 2, 3 up to infinite. At the n is the according to Maxwell Boltzmann and not into exponential of minus n by kt. So where is the n naught is the ground state, number of oscillation in the ground state. On other at the absolute temperature n equal to n naught n into exponential of minus en by kt at a temperature absolute temperature T. So we want total energy in the black body. The number of n atoms is there, n atoms is oscillated, n oscillations, n oscillation is at the absolute temperature is the according to Maxwell Boltzmann equation is this, and n equal to n into exponential of minus n by kt, or exponential v equal to E. So average energy E, average energy equal to, we write the number of atoms is the n atoms. N atoms energy is the n. So E1 atom, one atom energy is the E1, and second atom energy is the E2, and third atom is the energy is the number of atoms is the infinite. So average energy is the total atoms energy, adding the total energy E1 plus E2 plus E3 plus E4 up to infinite. So E1 energy is the 1 H is given the only 1 H. E2 is the 2 H energy. Then two energies, two atoms is given the, and three energy levels is the broad energy levels is the 3 H mu, 4 H mu up to infinite. The average energy, how to find out the origin up to this H mu is the infinite. Infinite adding is the not a possible. So using the another formula, average energy E equal to summation over n equal to 0 to infinite nn by nn into en by summation over n equal to 0 to nn. This one is the average energy formula. Okay, using this average energy formula is in the discreted values, not a continuous values, discreted values. Okay, so average energy. Okay. Summation over E equal to average energy equal to summation over n equal to 0 to infinite. Nn is the, we know that according to Maxwell Boltzmann, n at the absolute temperature is the n into exponential of e raised to or exponential minus en by kt into en also en. We write the en simply. And nn. En is the, we know that en equal to nh mu. And summation over n equal to 0 to infinite, nn equal to n into exponential of en by kt. Nn gets cancelled. Okay. And summation over okay, average energy E equal to summation over n equal to 0 to infinite e raised to minus nh mu by kt. En value is the nh mu, we know that. And En value is the substituting En value nh mu by summation over n equal to 0 to infinite e raised to minus nh mu by kt. Okay, this is the exponential. Expand. The summation is the expanded distributed. Suppose in the n place 0 to infinite, substituted 0 to infinite. The same. So e raised to 0. First one is the n equal to 0, 0 h mu by kt into 0 and place in the 0 by h mu plus e raised to minus all there already is there. n equal to 1 and n equal to 2 and n equal to 3 up to substituted the up to infinite. The same as denominator value also is the expanded by using of n equal to 0 to infinite. We know that already the how to expand e raised to minus 0 h mu by kt plus e raised to minus 1 h mu by kt plus e raised to minus 2 h mu by kt. So okay, this one is the e raised to 0 g equal to 1. So this one is the overall 0 equal to e raised to 0 equal to 1. So into 0, 0 into something is the 0. So this value is the 0 plus h mu, 1 h mu, I write h mu, e raised to minus h mu by kt plus 2 into h mu and e raised to minus 2 h mu by kt infinite. By denominator also same. E raised to h mu equal to 0 equal to 1. Okay, plus e raised to 1 h mu by kt plus e raised to h mu by kt up to infinite. So at the e raised to h mu by kt is the assuming the x. Suppose we take the x. Okay. Average energy equal to h mu x. This one is the take the already assuming x. So h mu x plus 2h mu x square plus 3h mu x cube plus up to infinite. By denominator value also same 1 plus x square because of 2 is there. E raised to 2 is the suppose e raised to e raised to minus 2x. I write e raised to minus x whole power 2. So this one is the x. So I write x. This one is the x. This one is the x overall e raised to minus h mu by kt is the x into 2 is the right the whole power 2. So x square. The same as other thing also same. Okay. And next. This one also same. So h mu x is the common out and h mu x is the common out. So the 1 plus 2 plus 2 into x square. So x square is there. So x only common out. So 2x plus 3x square plus up to infinite. And denominator value also 1 plus x square plus x cube. By using of binomial theory, h mu x and this equation, total equation according to binomial theory, 1 minus x whole power minus 2. Okay. And denominator value also 1 minus 6 whole power minus 1. So minus 1 minus 2 gets cancelled because of the at this are same. So minus 1 is the minus 2 is the cancel. We get the minus 1. We move to the denominator x 1 minus x whole power minus 2 plus 1 equal to 1 minus x whole power minus 1. So h mu x by this one is the minus 1 power minus 1. So this is the convert the numeric denominator value h mu x by 1 minus x. What is the x value? We know that h mu is the right the h mu. X equal to e raised to minus h mu kt because of we already assuming the x value. And x value is substituted e raised to minus h mu by kt. Okay. Next, e raised to h mu by kt is the overall this value is the multiply and okay. Numerator and denominator divides by the e raised to minus h mu. E raised to minus h mu, e raised to minus h mu cancel and 1 by e raised to h mu and 1 by e raised to minus h mu by e raised to minus h mu. Okay. This value numerator and denominator is the divides by e raised to minus h mu by kt. We get the value is the average energy equal to h mu by e raised to h mu by kt minus 1. Okay, this one is the Final value of the Planck's radiation law. What is the case one? Rayleigh Jeans is the fails. How to success in the Planck's law? Case one is the according to Wien's law. Wien's law is the what is the heading? Is the Wien's law is the only at a lower wavelengths, applying the lower wavelengths and higher frequency. Higher frequency means the infinite. So using this equation, the converting the lambda or frequency. This one is the only one atoms, one unit of the frequency. The number of unit of the frequency 8 E mu by d mu equal to 85 h mu by c cube into 1 by e raised to h mu by 80 minus 1. Substituting this equation, using this equation, only numerator value. This one is the numerator value. This value. Mu is the infinite. So infinite means this one is the e raised to infinite is the infinite. So minus 1 is the neglecting. So in the first case, minus 1 is the neglecting. The average energy h5 85 h mu cube by c cube into e raised to minus h mu by kt, because of this mu is the very high. In the case 2, higher wavelength or lower frequency. Rayleigh Jeans is the higher wavelengths. The same as higher wavelengths are lower frequency. Lower frequency is substituted 0, suppose. 0 substituted are minus infinite. Minus infinite, both this value is equivalent to the h mu by kt. So average energy equal to 85 mu square kt by c cube. The overall energy distribution is in the higher wavelength is this value and lower wavelength is this value. So what is the final mathematical expression is the average energy equal to h mu by 85 h mu cube by c cube into 1 by e raised to h mu by kt minus 1. This is the Planck's radiation law. So black body radiation law and Planck's radiation law. Okay. Thank you, all of you.